All right, guys. Here's this right on that book. All right, going over the problems for yesterday. Number 6, we are trying to find the largest triangle, or rectangle, and it tells us the rectangle has its base on the x-axis and its upper two vertices on the parabola 12 minus x squared. So first of all, we have to draw the parabola, draw our picture to get yourself an idea. So here's our coordinate plane. 12 minus x squared, my vertex is 0, 12, and it's opening down. So I draw my rectangle. And again, it doesn't have to be a perfect picture, just to give you an idea of what's going on. Alright, so we need to represent the side here. So from this point to this point is x, so because we're going to make this triangle bigger or smaller. So this would be x from here. So the whole base, the whole length of the rectangle would be x, and this would be the same because we are assuming that the rectangle is right in the middle. Because the parabola is symmetric, the rectangle would be right in the middle, even though my picture doesn't look like it. So this is x and this would be x. So therefore my length is 2x. My height, the distance from here to here, if this is x, then what is from here to here? Well, it's 12 minus x squared is what this would be. So if this was at 1, then my height would be 11. If this was at 2, then my height would be at 8, and so on. So here's my two expressions for my length and width. So therefore, here's my area, 2x times 12 minus x squared. And that's what we're going to maximize because we're looking for the largest rectangle. So we simplify. 2x times 12 is 24x. 2x times x squared is 2x cubed. So we take the derivative to maximize. Derivative of 24x is 24. And the derivative of 6x squared, 2x cubed is 6x squared. Alright, so now we're going to set that equal to 0. 24 minus 6x squared equals 0. And we're going to take the 24 to the other side, or the 6x squared to the other side. Divide by 6, 4x squared. Take the square root, we get x equals plus or minus 2, and we know x can't be negative 2, so it has to be 2. So if this length right here is 2, then the whole thing is going to be 4. Put 4 back into this equation here. 4 squared, I got this answer wrong, I believe. No, I did not, right? No, sorry, I put 2 in. I'm sorry, you're going to put 2 in for x. 2 squared is 4, 12 minus 4 is 8, so my height is 8. So I have a 4 by 8 rectangle inside this parabola. And again, as I said, this is going to be the toughest part for you, is to get these expressions. Draw yourself a picture to help yourself out. Think of your basic math or your algebra that we learned before that will help you get your information that you need. So we have a 4 by 8. They were asking for the dimensions, and they were asking for what is the largest area we can have. So 32 units squared. It didn't have any units, so that's why we just put unit squared. All right, number 12. All right, number 12 is talking about catching rainwater, and they tell you that the volume is 1,125. I want to write down as much as you can as I go. 1,125, and the volume of a square prism is length times width times height. They tell you that the base is a square, so that means both sides are x, and my height is y. So my volume equals x squared y. And again, we're always trying to find a relationship between the two variables. And so because I know the volume is 1,125, that's going to equal x squared y. And I want to solve for y because I want to get rid of the y in my equation that they give me. So I find out that y equals 1,125 over x squared. Okay, so they tell us that the cost is this equation here. So they helped us out a little bit. They gave us the equation that we're going to minimize or maximize. And here we probably want to minimize because we always want to minimize cost. All right, so I'm going to take the 1,125 over x squared and substitute it in for my y. So I'm going to simplify first. 5 times x squared, 5 times 4xy, plus 10xy. I add like terms, 20xy and 10xy is 30xy. So now I have 5x squared plus 30xy. Now I'm going to resubstitute 1125 over x squared and put it in for my y. I'm going to simplify again, multiply 30 times 1125 is 33,750, and x over x squared is just going to be over x. So here's my cost in the terms of x, which is what I want. Again, I want to minimize, so what do? I take the derivative. Derivative of 5x squared is 10x. Derivative of 33,750 over x. Remember, this is x to the negative 1. So I'm going to take the negative. There's my negative. Subtract 1 from the negative 1 gives me negative 2. So now I have 10x minus 33,750 over x squared. I want to get rid of the x squared, so I multiply everything by x squared. So 10x times 10x squared is 10x cubed. And when I multiply this by x squared, the x squared disappears. So 33750 equals 0. So now I'm going to solve for x. Take the 10 to the other side, 3375 x cubed. Take the cube root, and I find out the cube root is 15. So I know my x's are 15. 15 by 15. So now all I need to find is y. So I'm going to take the 15 and put it in for the x. So that's 225, and to 1125, I end up getting 5. So my dimensions of my prism, or my rectangular box that catches rainwater, and again, it doesn't have any top on it, is going to be 15 by 15 by 5. They gave me units. I didn't write the units there, but it should be feet. 15 feet by 15 feet by 5 feet. 15 feet by 15 feet by 5 feet. As far as the writing to learn, I'm not necessarily concerned with that. I just want you to be able to minimize and maximize your costs there. And again, if we can anything over 15 or less than 15, my cost would be greater because the 15 is the smallest, and that's what they're asking for in letter B. Give a possible scenario. So if I was bigger than 15, it would cost more to make. If I was less than 15, it would cost more to make. 15 is the ideal length for that base. All right, number 18. Number 18, we're designing a box with a lid. So here's our picture here. So basically we took a piece of cardboard that was 10 by 15. We cut out squares here, that was x, and we cut out a rectangle here that was x. But this part here is also x here, as they show, because it's going to equal this base. So we're going to fold it on these dotted lines. So this part folds up and becomes the cover. These folds up to be the sides, is what it amounts to. So we want to maximize, what did it say? We want to we want to maximize the volume. So we want to find out what kind of x's, what do we cut out, what squares do we cut out to be able to maximize. All right, so I know my width here, because this was 10. I cut out an x and I cut out an x. That one's easy. Width is 10 minus 2x. These fold up, so these are my height, so this is my x's for my height. Here, I got to remember this whole thing is 15. So if I take out this x and take out this x, that leaves me 15 minus 2x. Now I got two pieces that are the same size. I only want one piece, so I divide by 2. So that's where I get 15 minus 2x over 2. So now I have my length, I have my width, and I have my height. All right, and again, we're looking for volume of a box. Length equals width, or volume equals length times width times height. So letter A, they just want a formula or a equation for that. So we're just going to put length in for length, width in for width, height in for height. I get them switched around there, but it's the same equation. Letter B, they ask us, what is the domain? Well, remember, I can't be negative, so this has to be positive, so I have to have an x that is less than 5. If I have anything greater than 5, then I have a negative here, is what would happen. Same thing here, I need something that is greater than less than 7.5, but this overrides, so it has to be between 0 and it has to be less than 5. I can't cut out a square that is 0. That makes sense. All right, letter C, all you're going to do is to plug this into your calculator, see the graph, and find out where the maximum is. And we're going to find out that matches to what I do algebraically, which is letter D, to do algebraically. Okay, so here's my volume. I want to maximize volume, so I want to take the derivative, but first of all, I want to multiply everything together. So use the FOIL method. 10x times 15, 150x. 10x times 2x is negative 20x squared. 2x squared times 15 is negative 30x squared. And 2x squared times 2x is positive 4x cubed. And the 1/2 is still there. I can take the 1/2 and multiply everything inside. So 150 divided by 2 is 75. This is 50 divided by 2 is 25. And then I got 4 divided by 2 is 2. Then I take the derivative, 75 minus 50x plus 6x squared. And there's my equation that will maximize my volume. Now, most likely I'm not going to factor that, so I'm going to use the quadratic formula, which is negative b, 50, plus or minus b squared, 2500, minus 4 times 6 times 75, which is 1800, over 2 times 6, which is 12. Calculate it on my calculator. I do the 50 plus square root of this, divide by 12. That's going to be 6.37. 50 minus this, divide by 12, I get 1.96. Well, we already stated up in letter B that x had to be less than 5. So x can't be 6.37. So we can cross that out automatically. So I know that my x, the space of my x that I need to cut out is 1.96. 1.96 is the space that I would have to cut out. So they want to know what the maximum volume is. So we take the 1.96 and plug it back in for my x's. So 1.96 times 10 minus 2 times 1.96 times 15 minus 2 times 1.96 divided by 2. I get 1.96 times 6.08 times 5.54. That equals 66.0 inches cubed. And that should match the maximum, because remember, I should have a graph that looks something like this. This is x cubed, so it goes down and up. So it should be, this should be the maximum here. And it should be at 66.0, or they're very close to it on my graph. And it should match. So that is making the box with a lid, is what amounts to that. All right. Now this next one is a tough one. I don't have a problem if you didn't get this one, but it is a little bit of a tougher one. So we have a cylinder inside of a sphere. So basically a can inside of a ball. And it's inscribed, so that means all the corners of the can are touching the circle. or the sphere of the ball. So all those sides are touching. They tell us that the radius of the sphere is 10. So I drew my radius right from the center to the top. I drew my height of my cylinder, all right, which is h. All right, the center should be 1/2 of that, so 1/2 h. And then I have the radius of my can, which is r. So I need to find a relationship that I can use. My constant is the 10. That's what ties the sphere into the can. Volume of a can is pi r squared, area of the base, times the height. Pi r squared h. Okay, so what I need to do is find a relationship between h and r squared. Well, if I notice here, I have a right triangle. And what do I know about a right triangle? Pythagorean theorem. Hypotenuse squared, leg squared, leg squared. So 10 squared equals r squared plus 1/2 h squared. So when I square it, I get 100 equals r squared plus 1/4 h squared. And my goal is to get rid of the h. I want the r to stay. I want to get rid of the h. So I'm going to solve for h. Multiplied everything by 4. 400 equals 4r squared plus h squared. Subtract the 4r squared. Factor out the 4. Take the square root of that. And so I get 2 square root of 100 minus r squared. So there's my h. So here's my volume. V equals pi r squared times 2 square root of 100 minus r squared. Simplify, I get this here. All right, so now I have to use the product rule to take the derivative. I know I'm kind of scrunched up here, but I'm going to try to get you to be able to see what we did. Here's your first, here's your second, 100 minus r squared to the 1/2. So first, 2 pi r squared times the derivative of 100 minus r squared to the 1/2. So the 1/2 comes in front. Subtract 1/2. So 100 minus r squared, or subtract 1 to the minus 1/2, times the derivative on the inside, which is negative 2r. That's supposed to be a negative 2r there. Plus the second, 100 minus r squared to the 1/2, times the derivative of the first, which is 4 pi r. So here's my derivative right here. I'm going to simplify. So the negative 2 times the 1/2, or negative 2r times the 1/2 is negative r. Negative r times 2 pi r squared is negative 2 pi r cubed. The 100 minus r squared to the negative 1/2 is still there. And then we're going to simplify here, which is just 4 pi r times 100 minus r squared to the 1/2. So again, there's a little bit of math work here to do, but this is our derivative. Next, we're going to have to factor. So here's our derivative. This is where our derivative was on the other side of the page. So I moved to another page, so we spread ourselves out a little bit. So I'm going to factor out the greatest common factor. I'm going to factor out the negative 2, factor out a pi, and I'm going to factor out an r. All right, I'm always going to factor out a negative 100 minus r squared to the negative 1/2. So I'm going to take all that out. So when I take the negative 2 out, take the pi out, take an r out, and take a 100 minus r squared to the negative 1/2 out, I'm left with r squared. If I take a negative 2 out, I'm left with negative 2. Take the pi and the r out. That's the pi and r are gone. And now I take to the negative 1/2 out of 1/2. What do I do when I divide? I subtract exponents. So 1/2 minus negative 1/2 is 1/2 plus 1/2, which makes it 1. So that's why I have 100 minus r squared. Simplify on the side. R squared minus 200 plus r squared. The two r squares can be put together. 3r squared minus 200. So now I set each factor equal to 0. I'm going to take this factor, make it equal to 0. 2 pi r negative over square root of 100 minus r squared. Cross multiply. I get negative 2 pi r equals 0. divide by negative 2 pi, r equals 0. And of course, you know, you can't have a radius of 0, so that one doesn't work. And I take 3r squared minus 200 equals 0. Take the 200 to the other side, divide by 3, and take the square root. All right, that's r equals 10 square root of 2 over the square root of 3. Because 200 is the same thing as 2 times 100. Square root of 100 is 10, left with the 2 inside. And then if I want to rationalize, I multiply the top and bottom by square root of 3. So I get 10 square root of 6 over 3. That is my radius. That would give me the maximum size volume of a cylinder inside. All right, but they don't want just the radius. They also want the volume. So we have to find the height to go with that. So we take our height, which is 2 times 100 minus r squared, put the r back in, simplify, 600 over 9, 200 over 3. This is 300 over 3, which gives me 100 over 3. Square root of 100 is 10 over square root of 3. Rationalize. So 10 square root of 3 over 3. So that's 20 square root of 3 over 3. If I put those in decimals, I get 8.165 by 11.55. The volume would be, I didn't do that. Let me do that right now. So it would be 8.165 squared times 11.55. So 770 cubic, what was it supposed to be? Centimeters. 770 cubic centimeters would be the maximum volume. The maximum volume for that cylinder. So that was number 22, I believe. Is that right? Yes, number 22. Okay. All right, so we don't have any book work this time. We're going to just have MathXL 4.4c. I think on Friday you won't have a video. I'm just going to send you a worksheet that deals more with this. I know a lot of us are probably struggling with these word problems, and again, this next 3 sections deals with a lot of word problems. So we just need to make sure we're able to find the relationship. So tomorrow you're just going to work on, or today you're just going to work on page 258, MathXL 4.4c, 4.4c, and try to do your best on those as well. Probably when we get back from distance learning, we will really work on some of these during class to get us used to these. But this is it. This is what calculus is. It deals with a lot of practical applications with the derivatives that we use and the integrals that we're going to learn after this chapter. So page 258, MathXL 4.4c, and do your best on those. Don't worry if you get a lot of them wrong. I'm not grading right or wrong. I just want you to try them. Try to make sure that you show your work on paper and save your work on paper. So when you come back from distance learning, that if you have questions, I can see your work and I can see what you're doing wrong with the MathXL. So MathXL, make sure you write which MathXL it is. Write the problem down so I don't have to go back to MathXL, look at the problem, show your work, show your answer. This is what you put in for your answer. That way, that's the best way I can help you. Okay? Have a good day.